All right, so we have one mission and one mission alone today, and that is to figure out what is the distance between the Earth and the Sun. I know, deep stuff. All right, so let's go about this same way we always do. Let's start with a beautiful picture. Here's our Sun. You know what? Here, let's do. There's our Sun. It's a box, okay? Because apparently it only lets me do boxes. All right, so there's our Sun. All right, Sun. And then we have our Earth. Since we're in the boxes, let's just do the Earth. The Earth is green and it is blue. Boop, there we go. All right, so we've got the Earth over here. E-A-R-T-H. All right, so we got the Earth, we got the Sun. Now, the Earth is orbiting the Sun. Oh, well, the flat earthers are going to be on me. They're like, look, you made it flat. All right, so the Earth is orbiting the Sun. And the only force that's making it go in a circle instead of a straight line is the force of gravity. So, now that we've made our picture, now that we have our forces, our force diagram, we can do a net force equation. So let's bust that out. All right, so sigma F of C equals MAC. And again, I'm using centripetal because it is moving in a circle instead of a straight line, and the force of gravity is in that plane that's making it move in a circle instead of a straight line. So the centripetal forces are, well, it's just gravity. Now I could do a negative here, but I'm just going to go with everything's positive towards there. I'm not going to worry about all the crazy negative stuff. And so we've got MAC. So now normally we would replace the force of gravity with mg, but since we're working with universal gravitation instead of regular gravitation, we're going to bust out the big dog equation of Fg equals gmm over r squared equals m AC. Okay, so what are we going to replace AC with? Because we don't care about acceleration, we care about the radius. So I have to ask myself, what do I know about the Earth? I do not know the Earth's velocity. You might be that cool. I am not that cool. I'm sorry. I don't know its velocity, but I do know its period of rotation. It's a year, and I hope you knew that too. So I'm going to use the 4 pi squared r over t squared replacement for centripetal acceleration. And so then all I have to do is know its period of rotation. So the period of rotation of the Earth is equal to 1 year, which is equal to, anyone? That is, no, it's 365.24 days. I know, crazy. It's not actually 365 because, leap years are real. And in fact, if you look at that, that means that every 4 years we have our leap year, but doesn't quite make up for it. So roughly every 100 years, we need to have a double leap year to make it work. So this is in reality, here's the big numbers, 3, 1, 5, 5, 6, 7, 3, 6 seconds. All right, so that's the number that we care about. That's what we're going to be using for our period. All right, so now that we know that, all right, let's go through here. Let's see. Oh, look. This m and that m cancel out. Now remember, the big M is the mass of the object creating the field, and the little m is the mass of the object in the field. So the little m is Earth, and the big M is the Sun. So we don't need to know the mass of the Earth, but we do need to know the mass of the Sun. And you know what? I do not know that off the top of my head, but Google knows. And I already Googled it. So mass of the Earth is Sun. I said sun. You heard me. I said sun. Don't rewind this tape. Mass of the Sun is 1.99 times 10 to the 30th kilograms. All right. So, well, it seems like we kind of know everything we need to know. So we can do our replacement here. So G can be replaced with our gravitational constant, 6.67 times 10 to the negative 11th. And then big M is the mass of the Sun, which Google says is 1.99 times 10 to the 30th divided by r squared, which is equal to 4 pi squared r over t squared. And we now know t is 3, 1, 5, 5, 6, 7, 3, 6. Don't forget to square it. Super common mistake. I don't know why. Tons of students they just drop that bottom squared. Then they get tired of all the squareds and stuff. All right, so now all we have to do is algebra to solve for the radius. Now, this is where life gets fun. All right, check it out. So we're going to have to multiply both sides by r squared. That means this is going to go away, and this becomes cubed. Yes, cubed. Now, that means that when you're doing all these calculations, you are going to need to take the cube root of your answer. Now, I know how to do it with my calculator. I hope you know how to do it with yours. Now, I wish I could tell you how to do it with yours, but my calculator's from the year 1994. Okay, so, I mean, it's arcane compared to what you got. And if you don't know how to do it, literally type in how to take the cube root on Name Your Calculator into YouTube, and some kid will walk you through step by step. Okay? So, no stress, no worries. Use the internet for positive learning moments. All right. Now, I will also say this, that when you are punching this into your calculator, all right, so let's say I'm punching this part here into my calculator, I'm going to use the double E button. All right, the double E button. And it's going to end up looking like this, 6.67E. Why it's double E button on the calculator but only becomes 1E, I have no idea. It's always been something that irks me. Don't know why. So that would look like that. And if we were to do it to the sons, it would look like 1.99 E30. Okay, so whenever you see that E on your calculator, it means times 10. I like using it because it kind of treats it as an entire thing. If you want to use the times 10 option, you can. Just make sure you're really using parentheses hard. All right, now, when you do all this fun math, you get an answer of R equals 1496009812997 meters, which is insane. Like, no one wants to write that out. Okay, so instead we write that in scientific notation, and that would basically be 1.5 times 10 to the 11th meters. Fun fact, check that out in Google. Like literally Google, what is the distance between the Earth and the Sun? You will get this answer, proving physics is real. All right, so hope that helped. Hope this makes more sense, and I will see you guys in class next time. We're done.